everyone, welcome to Mech Intellects. In the previous class, we discussed about a standard Otto cycle efficiency. And now, in today's lecture, we discuss about some gate questions which were given previously. Okay, let us discuss. See, in 2003, this question was given for 2 marks. What is the question? For an engine operating on a standard Otto cycle, the clearance volume is 10% of swept volume. The specific heat ratio of air is 1.4. Then the standard air cycle efficiency is asked to find the cycle efficiency. What is cycle efficiency for Otto cycle? That is 1 minus 1 by R power gamma minus 1. This is Otto cycle efficiency, where R is the compression ratio and gamma is the specific heat ratio, that is Cp by Cv, and this was given as 1.4 in the question, so gamma is equal to 1.4. If you know compression ratio R, then you can find directly the cycle efficiency, right? Then how to find compression ratio R? What is compression ratio? Compression ratio is volume of the cylinder before compression by volume of the cylinder after compression. This is what we read in the previous lecture, right? Volume before compression means the total volume of the cylinder, that is clearance volume plus swept volume of the cylinder by volume after compression. After compression, there will be only clearance volume in the cylinder. Alright, and this can be written as 1 plus V swept by V clearance. Alright, we are just trying to find compression ratio, then we can find the cycle efficiency. Okay, but here the relation is given as clearance volume is 10% of swept volume, right? That means Vc is 10% of V swept. That means it is 0.1 into V swept. So let's substitute clearance volume as V swept by clearance volume is 0.1 times V swept. So 0.1 times V swept. V swept and V swept gets cancelled. So 1 plus 1 by 0.1, that is 1 plus 1 by 0.1 means 10. So we got a compression ratio as 11. So let us find efficiency of Otto cycle as 1 minus 1 by compression ratio as 11. So 11 power gamma is 1.4 given in the question. So 1.4 minus 1. If you calculate this, we will get efficiency as 0.6168. Therefore, we can write this as 61.68%. Next, we have another question from GATE. It was given in 2018, which is also for 2 marks question. Here, let's see. An engine working on a standard Otto cycle is supplied with air at 0.1 megapascal and 35 Celsius. That means initial condition, pressure and temperature. The compression ratio is 8, okay, that is R. The heat supplied is 500 kilojoule per kg. Property data for air, Cp value, Cv value, and characteristic gas constant. The maximum temperature in Kelvin of the cycle. అసలు కన్ఫ్యూజ్ అవ్వద్దు, ఏంటేంటో ఇచ్చేసాడు క్వశ్చన్లో అనేసి. ఏం ఫైండ్ అవుట్ చేయమన్నాడు? మ్యాక్సిమం టెంపరేచర్ ఇన్ ద సైకిల్. ఆటో సైకిల్లో మనకి మ్యాక్సిమం టెంపరేచర్ ఎక్కడ ఉంటుంది? జస్ట్ రీకాల్ ద ఎయిర్ స్టాండర్డ్ ఆటో సైకిల్. In PV diagram, air standard Otto cycle will be like this, right? Constant volume heat addition. This is 1, 2, 3, 4. This is compression process. This is constant volume heat addition. This is expansion process. And this is heat rejection process. If you look this in T and S diagram, 1 to 2 is isentropic. This is constant volume, and 3 to 4 is again isentropic. 4 to 1 is constant volume, right? So this is 1 to 2, 2 to 3, 3 to 4, and 4 to 2. In this cycle we got maximum temperature at 3. That means we need to find T3. How to get this temperature in the cycle? See, this 2 to 3 is heat addition process at constant volume. What is heat addition at constant volume? That is QA is equal to mCv T3 minus T2, final temperature minus initial temperature. Mass of gas generally taken as 1 kg, right? So 1 into Cv T3 minus T2. In the question, heat supplied is given as 500 kilojoule per kg, right? If you know temperature at point 2, you will know T3, right? Now how to get T2? How to get T2? See, from 1 to 2 is adiabatic process. In adiabatic process we have relation, that is Tv power gamma minus 1 is equal to constant. Just apply this for 1 to 2, we get T1 V1 power gamma minus 1 is equal to T2 V2 power gamma minus 1. So from this we can write T2 by T1 is equal to T2 by T1 is equal to V1 by V2 whole power gamma minus 1. Alright, so V1 by V2 generally volume before compression and volume after compression will be taken as compression ratio R power gamma minus 1, right? In the question, compression ratio is given. Compression ratio is 8. Okay, so 8 power gamma for air is 1.4 minus 1. So if you calculate this, you will get T2, that is T2 is equal to T1 into 8 power 0.4. T1 in the question is given initially at 35 Celsius, right? So 35 plus 273 into 8 power 0.4. So T2 will be 707.60 Kelvin. So now let's substitute this T2 in this equation you will get T3. Okay, so 500 is equal to 1 into 0.718. CV is given in the question 0.718. T3 minus T2. T2 is 707.60. So from this you will get T3 as 1403.98 Kelvin. So we got maximum temperature from the cycle. See, we used only two relations, that is heat addition at constant volume and adiabatic relation, that is Tv power gamma minus 1 is equal to constant. I hope you all understood. If you have any doubt, please raise it in the comment section. I will definitely try to answer them. Thank you.